Welcome to this segment where I would like to see how we can integrate event powers of sine x and cos x. So in the first part here, we shall have a review of the double angle formulae, because the substitutions which we'll be making will be based on the results you get from of the double angle formula here. So we consider a rectangle here. So we consider a rectangle here as R PQ, originally with the side PQ seated on the x-axis here, and then it is tilted such that now the side PQ makes an angle of B with the x-axis. So let us call the angle A the angle between the side PQ and the diagonal PR. So here we are saying that PR is the diagonal. Okay, this diagonal here is of unit length 1. So this point here, let's call this point U, and let us call this point V. We call this point T. Yes, and then we begin now a series of just manipulations. So maybe one thing here, this angle R here, it would be nice if you take some time and convince yourself that that angle R is B. It is the same measure. The measure of angle R is the same measure of this angle QPU. Okay, this one here, QPU. That the measure of angle QPU is the same as the measure of the angle R is, if I say R, it's wrong because it has this angle and this angle, so I'll be specific and then I'll call it QRT. So we'll call this QRT. They have the same measure. This is B. Okay. Yep. So yeah, you can easily follow through. Please just note that this is a right angle, then this is going to be 90 minus B, then this one is also going to be 90 minus B. This is a right angle, then since this is a right angle and this is 90 minus B, then this will be B. This is a right angle, so this is going to be 90 minus B, and this is 90, and therefore this is also what? 90. Okay, great. So we would like to start by now filling in the gaps here, because I wanted to make the video short. I just wrote down a few things so that we can just now start filling in. So we see A plus B is the measure of this whole angle, this one here. This is A plus B. So we are going to say that sine of A plus B is going to be equal to the opposite side. Okay, the opposite side, which is RU in this case. So we have that it is going to be equal to RU, which is the opposite, over, okay, the hypotenuse, which is PR. But remember, PR is of unit length. Okay, since PR is of unit length, then we can as well now write and then say that we know that RU is equal to sine of A plus B. Okay, since PR is of unit length equals to 1. Right, then we can also see that sine of, cos of A, the angle here, A, is going to be equal to the adjacent, which is PQ, divided by PR. Okay, PR, the hypotenuse. Okay, the cos of A equals to the adjacent, which is PQ, over PR. Again, we know PR is the diagonal of unit length, and so here we also come up with the result that PQ equals to cos A. In the same way, you please notice that the cosine of B, okay, the cosine of this angle here B, is simply going to be equal to, we can take the cosine of b to be written as, let's see, where's b? B is here. So the cosine of b is going to be given by the adjacent sides. Okay. Oh yeah, okay, let us make use of this b in the triangle. Maybe I have to be a little bit clear here, and then I specify which triangle we are using, since we have two angles which have the same measure b. So in this is the triangle RTQ. Okay, in the triangle RTQ. So we said that we can write cos of b to be given by RT, which is the adjacent, okay, the side adjacent to this angle here, B, okay, divided by the hypotenuse, which is RQ. Okay. Yes. So next we can say that now if we make RT the subject, we can say that RT is going to be equal to RQ times cos B. But I think we have a result of RQ somewhere. Do we have a result of RQ somewhere? Oh, not yet. Okay, so we can put a star here. I think we should have first computed the sine of A here, because let's see if the sine of A will give us a result which has RQ in it. This is A. Yes, sure. Sine of A, the sine is going to be equal to the opposite. If you see the angle here, A, the opposite side, which is RQ, okay, over the hypotenuse side, which is PR. Again, PR is of unit length 1, therefore we can say that RQ equals to sine A. So we see that RQ is equals to sine A, so we make this substitution here and place it here. Okay, where there is RQ, we can replace it with sine A. So this is going to be sine A cos B. And then using the same triangle here, RTQ, we can find an expression for sine B, because sine B we are going to say is equal to the opposite, which is going to be TQ, okay, divided by the hypotenuse, which is RQ. And then we can as well say make TQ the subject, which is going to be equal to RQ times sine B. Again, we know the result for RQ. We already saw RQ here is sine A, so we shall say that this is sine A and this is sine B. Okay. Yeah, so ideally, maybe someone would ask that where are we going? We will, in this first part here, we simply want to find the height of R above P. Okay, which height, okay, we can, which height is equivalent to RU, which is going to be given by the sum of the distance R to T plus TU. Okay, RT plus TU. So that is the direction in which we are headed. So for now, let me see, do we have RT? I think we have an expression for RT so far here. RT is already here. We need an expression for TU. Okay, we need an expression for TU, or okay, I think if we are not able to get TU, I think it's easier in this case, instead of saying TU, I think we can easily get an expression for QV, because it's, you know, it's much easier. If you look at this triangle here, it contains that angle B. So rather than saying TU here, let us use QV. So where's TU? Yeah, so I'll remove TU here and replace it with QV. Okay. Okay, so maybe I'll just make this smaller so that we can have everything in the same screen here. Okay, the next result, I don't want to get rid of the diagram here. I'll make this smaller, and then we'll do this here. So if we look at the triangle, maybe let us look at, I think we have a result here which may be hanging. I'm still not sure why we have TQ here. Maybe it will become apparent. Okay, maybe it will become apparent. The reason will become clear later on. Okay, let us first look at this triangle PQV. When we look at the triangle PQV, then we surely see that just a minute, PQV, let's see, P, Q, and V. Okay, we can get sine. Oh, okay, PQV. If you look at the triangle P, Q, and V, we could write and then say that, hey, we know that sine B, sine of this B here, is going to be equal to the opposite, which is QV, divided by the hypotenuse, which is PQ. Okay, so we can as well make QV the subject. I think since QV is of interest here to us here, so we can say that QV is going to be equal to PQ times sine B. And do we have a result for PQ anywhere? Oh, sure. Let me see. Yes, we have PQ. I think PQ is already here. PQ is cos A. So we have that, and that is going to be cos A and sine B. Okay? Yes, so we can go ahead and then say that our QV here, okay, I'll just highlight these results here. We are going to have our QV and then RT. Where is RT? Yes, and then our result for RT, which we got here. So we are going to RT and QV, we substitute into RU here. Okay, so we are going to say now that RU, which is equal to RT, okay, which RT we have already seen as sine A cos B, and then we add QV, which again we have seen as cos A sine B. Alright, however, please note that what is RU, I think we have RU, an expression for RU already given to us here before. And what is RU? RU is sine of A plus B, and then the right hand side we have sine A cos B plus cos A sine B. Okay, so this may not be the neatest derivations. However, this is the result, which I suppose some of you are already familiar with, that sine of A plus B, okay, sine of A plus B equals to sine A cos B plus cos A sine B. So that is the result which we have here. Okay, so I will just end here, and then so as not to make this very long, in the next video I will start with the other results.